Hey, Geometry. Mr. Mitchell coming to you from the home studio, a place I spent a lot of time last spring. So I'm making my video remotely today for the classes Thursday and Friday in all of geometry, and I hope to be back in the building as soon as I can. All right. So really, I'm thinking about being a virtual student here, and I don't have some of the tools I would normally have at school. So I'm going to try to do notes today from a distance using some technology tools that I hope you guys will feel comfortable using. So I'm really thinking about the virtual students today. And those of you in class with a Chromebook out, you can try this. It's a different way to take notes. And you might find that you like it. You get to save documents yourself that are made digitally. Okay, so I'm going to show you what I mean here. Let me reduce my picture. I'm going to put myself down in the corner here. All right. So I'm finding myself in a test classroom here, and let's say this is your classroom, and there's a PDF loaded for notes. Okay, it says special right triangles. Here's where I'm going to start. I'm going to use a couple of programs. The familiar look, if you click on a PDF, any teacher has sent you, is a black background. And what's different about my screen here is that in the top right, it says open with Kami, K-A-M-I. I don't want to talk about too much because I've done this in class, but Kami is an extension for Google Chrome, and it allows me to make changes to PDF and save those changes digitally. So I want to show you what it looks like. Because you have teachers that send you PDFs, right? You're like, oh, what am I supposed to do with this? Write on it, take a picture and send it back. Then I got to print. This is another way to do it. So I'm going to open with Kami the notes, and then I'm going to talk about these notes in the program and make changes. And so if you need to pause the video here and download that extension and get it to this point, allowing some permissions for Google Chrome in your account, maybe you want to do that. If you're in the classroom, you have paper, you can continue here because the changes I'm going to make or the notes I'm going to make, you can just write onto your paper. All right, so I'm in Kami now. It's still a web browser. I'm in the web browser. It's an extension that's open. So Mr. Mitchell is going to talk about special right triangles. Okay, they are right triangles. There's something special about them because of their angles. And let's just start at the top with a refresher on what an isosceles triangle is. All right. In your own words, write the meaning of a isosceles triangle. I'm going to come over here. I'm going to get a text box going. I'm going to make it a pretty big font size, 18, and then I'm just going to click right here. Okay, to me, an isosceles triangle, a triangle with two congruent angles and two congruent sides. All right, that's what it means to me. Ha! But I want to look at it. Let me show you another tool here. So I've now made this change, and it is saved to this document. You can see it saved up here. This is my version of the document, and I'm going to have some changes here. Okay, here we go. Let's add a triangle. Now look close. When I draw this triangle off to the right, check it out. It's giving me an isosceles triangle. I've got 42.3 degrees at the apex at the top, and both angles down here in the bottom corner are 68.6. If you remember, these should add to 180 degrees. I took my finger off the button. I have an isosceles triangle. I'm going to insert a line to say, all right, this side is congruent to this side, even if I don't draw them straight. And then I'm going to use a drawing tool, and I'm going to add congruence marks. If this side and this side, left and right side, are congruent, that means that angles that are opposite, this came from our work earlier this week, they are also congruent. So I've added congruence marks to my triangle. I'm so happy with that. I can make changes to a document without taking pictures, without writing on it in pencil. Okay, so I'm going to scroll down and let's see if I need to increase my size here so you guys can see it at home. All right, I'm going to go ahead and I'll see you later. I'm going to take my picture away just so we have lots of room to work. And you won't see me struggling with my mouse. Okay, well, here's a theorem. In a triangle that's isosceles with a 45, 45, and 90 degree, 45, 45, and 90 degree, the hypotenuse is the square root of 2 times as long as each leg. What in the world? This comes from the Pythagorean theorem. Okay, a squared plus b squared equals c squared. Maybe I won't get into the background on that, but here's what I'm going to write down in my own words. So I'm going to choose another text box. Here under notes, I'm going to say to find a hypotenuse, multiply the length of a leg of a 45, 45, 90 triangle by the square root of 2. Okay, the square root of 2 is not a mysterious number. We know it in math. It's 1.41 something. But often in math, people just leave it as the radical, they call it. They'll just say the length times the square root of 2. It's simpler to write that than it is to write the entire irrational decimal, which is a long number that does not repeat. Okay. Find the hypotenuse. You take x up here in the picture and you multiply it times the square root of 2. Take the leg, multiply by the square root of 2, and it'll give you the length of the hypotenuse. But we can go backwards too. To find a leg, given the hypotenuse, divide the length of a hypotenuse of a 45, 45, 90 triangle by the square root of 2. We can go backwards. If I'm given the hypotenuse and I need to find the leg, I can divide by the square root of 2. Okay, scrolling down a little bit. Oh, here comes the embarrassing part for me. I'm going to try to use my mouse to make some changes on this document. So I'm going to my little paintbrush on the left here, drawing tool. I'm going to try it with 1 as the width. And I'm going to review you on a couple of things to do with square roots. These are just square root basics. They've been covered in the past, but you may have forgotten it. Here I go. This is embarrassing. Okay, so the square root of 2. Okay, if I want to multiply the square root of 2 times itself, something special happens. I'm going to multiply it again times the square root of 2. I'm not all that unhappy with that. The square root of 2 times the square root of 2 is equal to 2. And this is a concept that we're going to need today. Okay, so this is a special note of refresher on some math. The square root of any number times the square root of any number equals the number. Keep that in mind today. I'm going to show you one more refresher. Here I go. Embarrassing. I'm going to try to make a fraction here. 1 over the square root of 2 Okay. 1 over square root of 2. Sure, that's a number. It's 1 divided by 1.14, etc. But if I was to leave this in radical form, which is to say leave it as 1 over square root of 2, mathematicians don't like having a radical on the bottom of a fraction. Here's how we're going to get rid of it. We're going to multiply this fraction times 1. Okay, but it's going to be a special 1 here. We are going to multiply it times the square root of 2 divided by the square root of 2. Whew. That's not too bad. Okay, so this is that fraction multiplied by 1. The square root of 2 divided by the square root of 2 is 1. But bringing in these radicals here will do something special. As you see above, on the bottom of the fraction, oh, that's a terrible fraction bar. So I'm just going to hit Control Z and it goes away. A little better. Bottom of the fraction, we multiply across. Square root of 2 times the square root of 2 is 2. So that has eliminated the radical on the bottom. And now 1 times the square root of 2. This is what I have on the top. Okay, so the left side of this, maybe a highlighter. The left side here is equal to the right side. There. They are equal. I've just multiplied by 1, which is the square root of 2 divided by the square root of 2. This is the method to eliminate the radical on the bottom of a fraction. 1 over the square root of 2 is equal to, they are equivalent to, the square root of 2 over 2. And we will use these two techniques today to simplify math. Okay. Let's look at 30, 60, 90 triangles. So a different right triangle where it's 30, 60, and 90 in the corners. And again, just like the 45, 45, 90, there's a special relationship. Now, this one is not an isosceles triangle. They're all different sides, but there's a mathematical relationship. It's simplified here. How about a square? It's simplified here with a couple of standard rules. And then I'm going to rewrite this as notes off to the left with my text box. Okay. To find a hypotenuse, multiply shortest leg times 2. What's here in the box? Shorter leg times 2 equals hypotenuse. The shortest leg is half the length of the hypotenuse of the triangle if it's a 30, 60, 90. And we can treat these like puzzles to figure them out. To find the longer leg, multiply, let's make that in all caps, multiply the shorter leg times the square root of 3. Okay, we're not going to spend time getting into why this is just today. We're going to practice how to use it. All right, I want to add one more phrase to the bottom of our page, and then we're going to look at some example problems. I'm going to come down here, start a new phrase. To reverse the above, which is what we did for 45, 90s, 45, 45, 90s, divide a hypotenuse. Either of 2, so divide the hypotenuse by 2 to find the shorter leg of the triangle, or divide by the square root of 3. That would take you from the hypotenuse to finding the long leg of the triangle. When a 30, 60, 90, you've got a short side, a longer side, and then as Ms. Sitek said the other day, the hypotenuse is always across from the 90. The shortest leg multiplied times 2 will give you the length of the hypotenuse. Kind of cool, right? The shorter leg multiplied by the square root of 3 will give you the longer leg. Okay, and here's a reminder. Remember that in formal math, fractions should not be left with a square root on the bottom, just the denominator. Okay, a little bit technical here. Just know that everything you need on the upcoming test, I think it's the end of next week, everything you need for reference is found here on this one page. So keep this handy. If you're working on the test at home digitally, you could open this document back up and look at this and see like, all right, well, they gave me a shorter leg. So I need to multiply that times 2 to get my hypotenuse of a triangle. Let's look at a couple of examples. The second page of your notes is going to look like this. All right. Now this is going to be, I'm going to do my best. I'm going to try to write either with text or with my crazy mouse some notes here. And I'm going to make space underneath for all 4. So I'm coming way over here to the left. And I'm going to write a text box here that says that in number 1, okay, if I'm given that the short side of a 45, 45, 90 triangle is 10, then I can figure out all the other sides from this. Okay, this is an X, and this one is also a 10. In our original picture, it was an X. This is 10, and this is 10. The short sides are 10. The hypotenuse is 10 times the square root of 2. So in this image, what they're asking for X is that it is equal to 10 times, I'm using an asterisk for times, the square root of 2. Now that doesn't look real helpful because that's me writing text. I don't have a symbol handy for the square root. So I'm going to try it with my pen. Oh man, I'm going to be embarrassed again. Here comes my pen. X is equal to 10. I think I can just go this and make a dot back to one size, the square root of 2. And that's it. 10 times the square root of 2 is what they're looking for here, the hypotenuse. So that is number 1. Okay, text box for number 2. Here. Oof, look at this. I have the 2 short sides of a 45, 45, 90, and they're given as the square root of 2 over 2. To find the hypotenuse, I multiply my short side times the square root of 2. Okay, here's what it would look like in print. X in number 2 is going to be equal to square root of 2 divided by 2, that's my short side, times square root of 2. All right. I'm going to have to do this one with my mouse so you guys follow along. Whew, here we go. What am I saying? Okay, we got X here is equal to this short side, which is the square root of 2 divided by 2. And if I want to get the hypotenuse, remember, I just multiply the short leg times the square root of 2, and I get that value. So it's a multiplication here. I'm going to put my dot. And I have to multiply it times the square root of 2. Okay, reviewing radicals. What happens when the square root of 2 is multiplied times the square root of 2? You at the back of the room, shout it out. What's the square root of 2 times 2? Excuse me, times the square root of 2. Square root of 2 times the square root of 2 is 2. Great. And it's still divided by 2 because the denominator has not changed. What is 2 divided by 2? That's right. It's 1. X is equal to 1. How about that? Square root of 2 divided by 2. It's going to be a very small number. 1.14 divided by 2. The hypotenuse of the triangle with these characteristics on the short leg. Multiply that short leg times the square root of 2, and your hypotenuse will come out to be 1. Well, I guess it's pretty cool in here that I could like box my numbers pretty easy. My answers, there's 1 there, and there's 1 there. To save myself some room, I'm not going to do number 3, but I'm going to tell you that whatever this x is gets multiplied times the square root of 2 to equal 8 square root of 2. So what's x? Think about it logically. Something times the square root of 2 equals 8 square root of 2. And these are multiplications here. So x is equal to 8. Excuse me. There's the answer to number 3. Turn and talk to your partner after we finish here if you're not sure what happened on number 3, because some of these will come up in today's assignment. 8 times the square root of 2 is 8 times the square root of 2, left in radical form. Okay. Here we go. Number 4. And this one takes a little bit of work. I'm going to do it in text box form. It's tricky. But I got lots of room here. All right. What I know of 45, 90s is that if you take the short leg, here it's x, I multiply it times the square root of 2. It's in text form. It will equal my hypotenuse. So this is how I can set up my equation from the beginning. X times the square root of 2 equals 12. Well, now what? I have to figure out what x is. Let's try it in print. Bear with me, this is going to be a challenge. I'm going to rewrite it. X times the square root of 2 equals 12. I'm going to treat this like general algebra. I'm solving for x. So I can divide both sides by this square root of 2. See how nice it is not to deal with decimals? I'm going to make a division on both sides. X divided by square root of 2 should give me x by itself on the left. But I have to do it to both sides. These will cancel. Okay, so I'm left with x is equal to 12 divided by the square root of 2. It's going to look sloppier as I try to speed up. Let's do that trick that we did up above here on our first page. We do not want to leave radicals on the bottom of a fraction. It's not proper math. If you ever worked with Mr. Wilshire, he would go crazy if you do this. Okay, so I'm multiplying the left and the right side of the equation by 1. X times 1 is 1. I will make no changes there. But here, I'm going to multiply times 1 that is in a different form. Any number divided by itself is 1. So this is an expression that means 1. Okay, 12 times the square root of 2. I'm just going to move this down. 12 times the square root of 2 in simplest radical form. Oh, I don't like those. Control Z twice. Is just 12 times the square root of 2. The square root of 2 times 2 is equal to 2. So this is now equal to, I can simplify this once. 12 times the square root of 2 divided by 2 gives me 6 times the square root of 2. Final answer. Give it a square so we know that this is the answer. Okay, you may be challenged with these today. Let's look at a couple with the 30, 60, 90 exercise here. They are giving you 2 variables to solve for based on the theory of a 30, 60, 90 triangle. Across from the 30 is my shortest side. It says 15. Okay. Oh, I remember this. Take the shortest side, multiply it times 2, and you give the hypotenuse. Let's do this one as a text box. So y is equal to 2 times 15, or that's 30. Damn, we're done with one. Nice. If I take the shortest side, multiply it times 2, that gives me the hypotenuse, y. Nice. Ooh, but x. X is equal to the short side, 15 units of length, times the square root of 3. Square root of 3. So in the 30s, I'm going to flip up here just to look at my picture again. You take the short side to get the longer side, not the hypotenuse. You multiply x times the square root of 3. So that is what we've done here. Try it in print. X equals 15 times the square root of 3. If there's no, that's terrible. Look at that. If there's no multiplication sign with a radical, it is implied here. 15 times the square root of 3. How you doing, guys? We're almost there. Here we go. I've got a 30, 60, 90 triangle in number 6. And I know I have one because I've got a 60 here and a 90 here. So this has to be a 30 up in this corner. That has to be a 30. They've given me the hypotenuse of 22. Let's look at that sentence up above. Okay, hypotenuse is the shorter leg times 2. Let's turn that straight into our math sentence. Hypotenuse is the shorter leg times 2. Okay, 22 is my hypotenuse. Is my shorter leg, that looks like y times 2. Let's use Mr. Young's trick here. It's an algebra expression. What number times 2 equals 22? Good job. Y is equal to 11. So we just took the hypotenuse and split it in half to find what the shorter leg of the triangle was. And here comes one with a little more to it. The longer leg is the shorter leg times the square root of 3. X is equal to 11. We figured out that short leg times square root 3. I'm going to move this over just so it's all lined up here. And that is a final answer because we're leaving this in radical simple form. We're going to leave square root of 3 in our answer, and it would look like the one to the left. So take a minute to draw boxes. We got X and Y defined over here, and X and Y defined over here. Okay, last challenge. I have the longer leg of the triangle given to me. I don't know the hypotenuse. I don't know the shorter leg. Wow. Okay. But I do know some things from up above here. Okay. Shorter leg. Longer leg is shorter leg times the square root of 3. Hypotenuse is the shorter leg times 2. Well, all I know about is the longer leg. So I'm going to use this second phrase here. Longer leg is shorter leg times the square root of 3. Longer leg, 9, is equal to the shorter leg, here is X, times square root of 3. Okay, let's take this to my terrible mouse drawing. 9 is equal to X times square root of 3. Oh, not too bad. Okay, I want to solve for X. That's my shorter leg. That means I have to isolate X by itself. So I'm going to divide both sides by the square root of 3. Well, we're going to find ourselves with a radical on the bottom again. And we'll have to take care of that. Okay, but these are going to cancel. Square root of 3 divided by square root of 3. So 9, a little better 9, divided by the square root of 3 is equal to X. Oh, here's that thing. Let's get rid of the radical on the bottom. X times 1 is X, so we're going to leave the right alone. The left side we're going to multiply times 1 also, but we're going to put it in the form of the square root of 3 divided by the square root of 3. And then here's my multiplication right there. Square root of 3 times 9, well, I can just reorder that. That's 9, nope, 9 times the square root of 3. And then on the bottom of the fraction, I have the square root of 3 times the square root of 3, and that is 3. And I can simplify this. 9 divided by 3 gives me 3, and I keep that radical on the top. 3 times the square root of 3 is equal to X. Let's put a box on that so we can concentrate. We have figured out X. Stay with me. This is my last example. So that's X. Oh, nice. I understand here. I'm going to work up right next to the triangle. That X times 2 gives me the hypotenuse in a 30, 60, 90 triangle. 3 times the square root of 3 is my X. So my Y my y is going to be 2 times x, or 3 times the square root of 3 times 2. And maybe it's been a minute since you did this either. How do we handle this? 3 times the square root of 3 times 2. There's really 3 things multiplied. We can leave the radical out of this, multiply 3 times 2. Okay, we're going to leave it in simplified radical form. 3 times 2 is 6. And then we just leave this square root of 3 as part of the equation. Let's put a box around that, put a bow on it, call it done. I appreciate your patience. I've tried to make shorter videos this year, but this one at home gave me some challenges, so we had to add some for technical difficulties. But I hope this has maybe showed you a new tool. Let's say I want to make sure I've got everything saved in my Google Classroom. I would just go up here to a couple of options. On the top right, I've got print, document with annotations. It's going to make a PDF for you, and you can save that PDF anywhere you want on your Chromebook or your computer at home. I can save and make all kinds of special changes. I can change where it's going to be saved in my computer according to where my account wants me to put it. I can put in all these locations. It'll show you your Google Drive. I'm not going to do that just for now. But I'm going to say, good luck in today's assignment. You're going to find 14 problems that are similar to the exercise here. Think about 45, 45, 90. That's the beginning of it. 30, 60, 90 is the second 4. And on the back, they are mixed. And teachers, it's your discretion on whether you want to grade 13 and 14. But I put these in here so that the students can start seeing these like the puzzles that they are in geometry. Can you figure out a missing side X when you're given multiple triangles? Good luck in review of your radical math. We will be in the room to help. And kids at home, I hope you'll send messages anytime you run into a roadblock on that. Good luck, crew, on your assignment, and I appreciate your work. Bye for now.